The first 24 hours after death. Life ends, but the body's story is just beginning. What really happens to the human body in the first 24 hours after death? When we think about death, many picture an instant, alive one moment, gone the next. But scientifically, it's a complex, multi-stage process. Our journey into the first 24 hours starts with understanding two key states: clinical death and biological death. Clinical death is that moment of death when the heart stops and breathing ceases. The person loses consciousness, there's no pulse, and pupils don't react to light. Crucially, the brain and other vital organs haven't yet suffered irreversible damage. Brain cells, although starved of oxygen, have a small energy reserve, lasting 3 to 6 minutes. This is a critical window. CPR, chest compressions, and rescue breathing can bring someone back. It's where return is possible. If circulation isn't restored within this window, biological death occurs. This is irreversible. It marks widespread brain cell death due to oxygen deprivation. Neuron death makes a return to life impossible. But biological death doesn't happen to all cells at once. Some tissues, like muscle or skin, can survive much longer, several hours. This makes organ transplantation possible. So death isn't a switch, it's a sequence, gradually encompassing the entire body. Did you know that even after the heart stops, the brain might show activity? What happens to our main engines in the first minutes and hours after death? The heart, our tireless pump, works non-stop from the moment we're formed. When it stops, a chain reaction of irreversible events begins. At clinical death, the heart stops contracting and blood stops circulating. This instantly deprives all organs of oxygen and nutrients. Without these vital elements, cells begin to starve and die. The brain, the most energy-intensive organ, suffers first and hardest. While clinical death gives us a few minutes for resuscitation, the brain begins experiencing severe oxygen starvation, hypoxia. Interestingly, research shows a short burst of electrical activity in the brain seconds after the heart stops. It's like a last-ditch effort to reboot before final shutdown. Some scientists link this to near-death experiences, but the mechanisms are still under study. Besides the brain and heart, other vital organs suffer. Kidneys stop filtering blood. Lungs can't exchange gases. All systems that worked in perfect harmony gradually shut down. It's not an instant power off, but a gradual fading, where each organ follows the central command center and the pump. No one will tell you about how relentlessly the body begins to cool and what hidden processes of decay are triggered at the cellular level in the first hours after death. As life ebbs away, the body starts its own amazing and slightly disturbing journey. One of the first and most noticeable processes after all life functions cease is cooling. Scientists call it Algor Mortis, or death chill. Our bodies, being warm-blooded, maintain a constant temperature of around 98.6 degrees Fahrenheit. But without the internal heating system, metabolic processes, it begins to lose heat, gradually reaching ambient temperature. The cooling rate depends on many factors: room temperature, clothing, body size. On average, the body loses about 1 to 1.5 degrees Fahrenheit per hour in the first 12 hours. This isn't just a physical process. It's a key marker helping forensic scientists estimate time of death. Simultaneous with external cooling, more fundamental changes occur inside the body at the cellular level. When circulation stops, cells are deprived of their lifeline, oxygen and glucose. Initially, they try to survive, switching to anaerobic metabolism without oxygen. But this is inefficient and quickly depletes energy reserves. Toxic byproducts like lactic acid build up, changing internal acidity. This triggers a process known as autolysis, self-digestion. Cell membranes break down, and enzymes that were once safely contained within organelles and responsible for processing substances are released, beginning to break down the cell from the inside. This is the beginning of degradation, gradually affecting all tissues and organs. So in the first hours after death, the body isn't just sleeping, it's actively changing, preparing for the next phase. Imagine the body after death starting to change, leaving mysterious clues about the time and circumstances of passing. These silent witnesses appear as amazing, sometimes gruesome, transformations that become visible within the first hours. After the body cools, external changes begin, serving as a kind of clock for experts. We're talking about rigor mortis, blood pooling, and rigor mortis, stiffening, two key markers forming in the first 24 hours. Rigor mortis arises from the gravitational pooling of blood. When the heart stops, blood settles in capillaries in the lowest parts of the body, discoloring the skin to a bluish-purple hue. The first vague spots appear after 20 to 30 minutes, distinct ones after 1 to 2 hours. Full formation takes 8 to 12 hours. Before this, they can be moved by changing the body's position. After 12 hours, they become fixed, permeating the vessel walls. This helps forensic scientists understand if the body was moved. Simultaneously, rigor mortis develops. This is the stiffening of muscles caused by biochemical changes. In life, muscles contract and relax using ATP energy. After death, ATP production stops, and without this energy, muscle fibers remain contracted, causing rigidity. Stiffening begins 2 to 4 hours after death, first in small muscles, jaw, eyelids, then spreading to the limbs. It reaches maximum intensity in about 8 to 12 hours, affecting all muscles. This state lasts 24 to 48 hours before resolving due to muscle protein breakdown. Both phenomena are accurate indicators, helping reconstruct the events of the last hours. By the end of the first day, the body initiates amazing processes that can accelerate decomposition many times over. Just 1 degree of external temperature change can alter the rate of these transformations by 10 to 15%, demonstrating the fragile boundaries between life and oblivion. So, by the end of the first 24 hours, the body enters the decomposition phase. Autolysis, self-digestion, continues, but now putrefaction joins it. Bacteria, peacefully living in the gut and on the skin, unchecked by the immune system, begin to actively multiply and spread. This is putrefaction. By this point, the first, barely noticeable external signs of putrefaction may appear. A slight discoloration of the skin, especially in the abdomen, and possible gas formation, causing slight bloating. These gases are products of bacteria actively breaking down organic matter. The speed of these processes critically depends on external conditions. Ambient temperature is key. The warmer it is, the faster bacteria multiply and chemical decomposition reactions occur. As we mentioned, a change of just 1 degree can speed up the process by 10 to 15%. Humidity is also key. High humidity promotes microorganism growth, while dryness can lead to mummification. Clothing, body size, and cause of death, e.g. infection, all contribute. By the end of the first day, the body is no longer just cooled and stiffened. It's actively transforming, obeying the laws of nature and external conditions, beginning its journey back into the cycle of matter. We've journeyed through the scientific mysteries of the first 24 hours after death, but what about what lies beyond the physical? If you're ready to explore more mysteries surrounding our spirit and existence, subscribe to Mysteries of the Spirit and like this video. Together, we'll continue to uncover the unknown,